Alright, we are on section 1.7, which is transformations of functions. In section 1.6, we learned what the parent functions were. We had the, well, let's see, we had the square graph, we had the cube graph, we had the square root graph, the absolute value graph. Let's see, what else do we have? The reciprocal graph. Okay, and we also had the step function. We're not going to be worrying about the step function much in this section. Those are the main five. And now we're going to be dealing with transformations of them, more specifically than we did in the last section, which means that we're going to be dealing with motions that move the graph up, down, left, right, or make them skinny or fat, and also reflections. So I'm going to break this into three different parts. The very first part is going to be dealing explicitly with vertical and horizontal shifts, moving it up, down, or left and right. The second video is going to be dealing with non-rigid transformations, which is basically changing the shape slightly by making it skinnier or fatter. And the third video is going to be devoted to reflections. So let's dig into the first transformations. What I want you to recognize is that our graph is, or our equation is going to be in this format for the most part. Alright, we have three terms that affect this graph: this A term, this H term, and that K term. All three of those affect the appearance of this graph. A makes it skinnier or fatter, and that's going to be on video 2. A negative on A also affects it, and we'll talk about that later. H moves the graph left or right. K moves the graph up or down. So we're going to be dealing with that H term and that K term in this video. Now what I want you to recognize is that this f of x minus h, if you ignore the x minus h and just think about it as being f of x, okay, that is going to tell you what your parent function is. Okay, it could be a square function, could be a cube function, could be any of those five that we discussed a second ago. Okay, so what do I mean by that? Well, here are two examples of functions that are transformed, but you should be able to recognize instantly what the parent function is. Alright, our first function, and I didn't use any numbers in it, but I have this right here. It's basically the parent function. So obviously that is the quadratic or the square function. How about this one? Those lines there tell you that it's an absolute value. Okay? So that's where you start. You look at it and you figure out, okay, what's the parent function? Okay, in the first example it's x squared. What do we do with it from there? In the second example it's absolute value. What do we do from it from that point? Alright, so first let's take that parent function that looks like this, y equals x squared. And now let's give it a h and k transformation and see what it looks like from there. What would this graph look like? Okay, we have a vertical and a horizontal shift on it. Okay, first I want you to look inside the parentheses. That minus 2 is a horizontal shift. It means it moves it 2 spots to the right. Okay, so first it's going to look like it's there. And then we have that minus 5 on the outside, which means that the entire graph moves down 5 spots. Okay, those are the only two transformations that are on there, so that's the final graph, and that's all there is to it. So basically, you start off with what does your parent function look like, and then where does it move from there? Okay, now what I want you to remember is that the basic formula is x minus h in parentheses. Okay, so a minus h means that it moves to the right. It seems kind of counterintuitive, but that's the way it works. If it were a plus 3, then it would move left 3 spots. And then another thing that I want you to consider is this. If this is the basic function, then what this is saying is your y value is going to be whatever the basic function is minus 5. And the y value is up and down. Alright? So instead of being here, it's down 5 spots. Okay, so that's another way of looking at that. Let's take another example. What kind of function is this? This is a square root function. So what I want you to do is pause this video and think about what this graph might look like, and maybe graph it out on your own. Don't be lazy, do it. Alright, look inside the parentheses or inside the function first. That's that plus 6. It means we need to move the graph left 6 spots. Alright? Then we have that plus 2. That means the graph moves up 2 spots. And that is your final graph. Okay, so it all comes back to what the parent function is, and that's why we spent last section working on those parent functions. This same thing moves left 6, up 2, and we're done. Okay, that is the end of this video. Sayonara.